Integration of exponential functions. Meron tayong dalawang formula na dapat tandaan sa topic na ito. Number 1, integral of e raised to u du equals e raised to u plus c. And number 2, integral of a raised to u du equals a raised to u divided by ln of a plus c, where a here is a constant greater than 0 and not equal to 1. Ang derivative ng e raised to u ay e raised to u du. Kaya pag ni-reverse natin yung process, integral of e raised to u du will become e raised to u plus c. Ang derivative ng a raised to u divided by ln of a equals sa a raised to u du. Kaya pag ni-reverse natin yung process, integral of a raised to u du will become a raised to u divided by ln of a plus c. So sa mga formula na ito, yung du ay derivative ng exponent na u. At ang mga ito ay general form. Kaya kung meron tayong integral of e raised to u du equals e raised to u plus c, it follows that integral of e raised to x dx equals e raised to x plus c. Integral of e raised to y dy equals e raised to y plus c. Integral of e raised to t dt equals e raised to t plus c, and so on. So, ganun din dito sa formula number 2. Okay, so paano gamitin yung mga formula na ito? So, let us have example. So, example number 1, no? Let us say, meron tayong integral of x e raised to 3x squared dx. So this is also equal to the integral of e raised to 3x squared and then times x dx. So yung ginawa natin, pinagtabi natin yung x at ang dx. So, dito sa topic na ito, ang ile-let u natin ay yung exponent ng e, 3x squared, no? So, let u equals 3x squared. Kaya rin nun, kukuha tayo ng derivative both sides, ano, in differential form. So, magkakaroon tayo ng du equals 6x dx. Kaya rin, mayroon tayong factor na x dx dito sa ating problem. So, solve natin siya in terms of du. So, magkakaroon tayo ng 1 over 6 du equals x dx. After that, gagawin natin, yung problem isusulat natin in terms of u. So, meron tayong integral sign, meron tayong e raised to 3x squared. Yung 3x squared equal na siya sa u, was times x dx. But you see, x dx equals 1 over 6 du. So, times 1 over 6 du. So, yung 1 over 6 ay constant, pwede natin siyang isulat sa labas ng integral sign. So, 1 over 6 integral of e raised to u du. At pwede na natin ngayong i-apply yung ating formula. Integral of e raised to u du equals e raised to u plus c. So 1 over 6 e raised to u and then plus c. Kaya rin yung value ng u ay ibabalik natin, 3x squared. So 1 over 6 e raised to 3x squared and then plus c. At ito na ngayon yung ating sagot, ano? Okay, shortcut method tayo, no? Shortcut method tayo. So, meron tayong integral of e raised to 3x squared times x dx. So, dito sa formula, no, as I have said, ano, yung du ay derivative ng exponent na u. So, yung ating exponent ay 3x squared at ang kompletong derivative niya ay 6x. So, kung may 6x dito, ay magiging integrable na yung problem natin. So, dahil kulang ng 6 yung derivative ng 3x squared, so ang gagawin natin ay maglalagay tayo ng 6, ano, magmumultiply tayo ng 6 para makompleto yung derivative ng 3x squared. So, e raised to 3x squared, so times 6x dx. So, ito na yung derivative ng 3x squared. So, para hindi mabago yung problem, at the same time, dapat ay magmultiply din tayo ng 1 over 6, ano? So that 1 over 6 times 6 is 1. So the same problem pa rin, no? Equal pa rin itong integral na ito dito sa ating problem. So meron na tayo ngayong 1 over 6 integral of e raised to u du, no? So integrable na ito. So magiging 1 over 6, no? So applying the formula, ang sagot natin ay e raised to u. At ang u natin ay yung 3x squared. And then plus c. And this is now our answer using the shortcut method. Ano? Example number 2, meron tayong integral of e raised to tangent of 3 theta d theta divided by cosine squared of 3 theta. So let u be the exponent of e. So let u equals tangent of 3 theta. Kaya ngayon, kukuha tayo ng derivative. Du derivative of tangent is secant squared of 3 theta. And then times the derivative of 3 theta, 3 d theta. Kaya rin nun, dito sa ating problem, meron tayong factor na d theta divided by cosine squared of 3 theta. So, ang gagawin natin, solve natin yon in terms of du. So, multiply both sides by 1/3. So, 1/3 du equals d theta divided by, ayun, yung secant squared of 3 theta equals sa 1 divided by cosine squared of 3 theta. So 1 divided by cosine squared of 3 theta. Kaya rin nun, yung ating problem, susulat natin in terms of u. So meron tayong integral sign. Meron tayong e raised to tangent of 3 theta. But tangent of 3 theta equals sa u. And then times d theta divided by cosine squared of 3 theta. And it is equal to 1/3 of du. So 1/3 du. So yung 1/3 ay constant. We can write it before the integral sign. So e raised to u du. At pwede natin ngayon i-apply yung ating formula. So magkakaroon tayo ng 1/3 e raised to u and then plus c. Kaya rin nun, sa-substitute natin yung value ng u na tangent of 3 theta. So 1/3 e raised to tangent of 3 theta and then plus c. And this is now our answer. Example number 3. Integral of e raised to 2y times e raised to 3y dy. So, ang gagawin natin, no? Mumultiply natin yung e raised to 2y at saka e raised to 3y. And this is equal to e raised to 5y dy. Ngayon, ang kompletong derivative ng 5y ay 5 times dy, you know. So, kung may 5 doon, ay magiging integrable na yung ating problem. So, dahil walang 5, no, derivative ng 5y, ang gagawin natin ay maglalagay tayo ng 5 doon sa ating integrand. So, e raised to 5y times 5 dy. And at the same time, magmumultiply din tayo ng 1/5 para hindi mabago yung problem, no? So, meron na tayo ngayong integral of e raised to u du, no? At integrable na siya gamit yung formula number 1. So, 1/5 integral of e raised to u du equals e raised to u. At yung u natin ay yung 5y. And then, plus c. And this is now our answer. Example number 4 tayo. Integral of e raised to 2x dx divided by e raised to x plus 1. So, yung ating integrand ay improper fraction. At ang integral ng improper fraction equal siya sa integral ng quotient plus the remainder. Kaya ang gagawin natin, i-divide muna natin yung e raised to 2x sa e raised to x plus 1. So, e raised to 2x divided by e raised to x plus 1. So, e raised to 2x divided by e raised to x equals e raised to x. Tapos multiply natin, e raised to x times e raised to x plus 1 equals e raised to 2x plus e raised to x. Subtract, no? So, e raised to 2x plus e raised to negative 2x equals 0. And then, negative e raised to x. So, hanggang dito na lang yung division natin para yung ating remainder ay maging integrable magiging integral siya leading to natural logarithm. So, ito ay equal ngayon sa integral of the quotient e raised to x and then plus the remainder, no? So, plus negative e raised to x divided by e raised to x plus 1. And then times dx. Tapos, pag-iwalayin natin yung integration ng bawat term. Magkakaroon tayo ng integral of e to the x dx. And then minus integral of e raised to x dx divided by e raised to x plus 1. So ito ay integrable na, no? Gamit yung formula number 1. Integral of e raised to x dx equals e raised to x. And then minus. Ito naman, yung ating numerator ay eksaktong derivative ng ating denominator. So, nasa form siya ng integral of du over u equals ln of u and then plus c, no? So, yung u natin yung e to the x plus 1 at yung du natin yung e to the x dx. So, pag in-apply natin yung formula na ito, magiging ln of e raised to x plus 1 and then plus c. At ito na yung ating sagot.